Hi, and welcome to the video for your Monday homework. Remember, I will be checking both Edpuzzle that you've watched this video and your notebooks for the notes and practice that you will see in this video. All right, let's go back to our map because what we've been doing is we've been building roads between the four different representations and the classifications of polynomial functions. So last time we were together, we built this road from data table to classification. So now y'all should be able to classify a polynomial function from the data table using successive differences. So that road is now open to us. We still have some roads that are blocked, and the next road we're going to work on is building the road from data table to formula or equation, meaning we should be able to write the formula for a polynomial function if we're given the data table. So this is the next road we're working on. Before we do that, though, we kind of have to know a little bit about the general formula of polynomials. So all polynomials have a general formula. So let's look at some examples so you understand what I mean. If we start off with a linear polynomial, for example, the general formula of a linear polynomial is f of x equals ax plus b. And what you may notice here is that on the example underneath, a is 3, that is the coefficient in front of x, and b is 7, that is the constant at the end. Now you may be thinking, wait, I thought that the formula for a linear function is y equals mx plus b. That's true, but in order to be consistent, we're going to be using the same system for all polynomials, and other polynomials follow this a, b, c, d type system. So to demonstrate that, let's look at the next example, which is quadratic. For a quadratic, you may have seen this before, the general formula is f of x equals ax squared plus bx plus c, where a is the coefficient in front of x squared, b is the coefficient in front of x, and c is the constant at the end. So in this example, a is 5, b is -7, and c is 9. The last example we were going to look at is a cubic. So again, it follows a similar trend where we have f of x equals ax cubed, plus bx squared plus cx plus d. Here, a is 1 in the example, b is 7, and c is 0. And I'm going to show you what happens when you have a coefficient of 0 or 1, and d is 12. So what happens when you have a coefficient of 0 or 1? For 1, you'll notice that the term, as you should probably know this already, x cubed will remain, but we don't write coefficients of 1 typically. In the case where the coefficient is 0, this term disappears completely, and that's because 0 times x is 0, so we would not write 0 at all. And so you would have something that looks more like this, x cubed plus 7x squared plus 12, and it just looks like there's a missing term there. All right, now we're going to go into your notes. So the first thing you need to do for your notes is you should have your composition book ready. At the top right-hand corner, you're going to write the page number, whatever page you're on now. Left-hand corner, you're going to write your date, and the title is Writing the General Formula of Polynomial Equations. Pause the video as necessary when we go through the notes, because you have to have these notes filled in. Okay, we're going to talk about some steps for writing the general formula of polynomial equations. Before I go through these steps, you may notice as you see these steps that there's a better way of doing it for you. I'm totally okay with you not following these steps, but I'm going to write them down so that we all have them. And then later, as you're working on writing general formulas, if there's a better way for you to do it, go ahead and do it. Okay. Before we write down the steps, I need you to draw a vertical line, and I want the left side of the vertical line to have a little bit more space than the right side. So this is going to be a little bit bigger than half of the page, and this is going to be a little bit less than half of the page, because here we're going to actually write the steps, and here we're going to do the examples. So we need less room for the examples. So let's look at the steps. The first step is to use the classification to identify the highest exponent or power. Second step is to list all the term in standard form from highest to lowest powers. Third step is to separate terms with a plus sign. All of our terms in the general formula are separated with plus signs. And 4, write in the coefficients in alphabetical order. So we write those in last, A, B, and C, etc. Now on the right side of that vertical line there, I want you to write in, for the example, write general formula of a quadratic polynomial. And that GN is just abbreviation for general formula. So the first step is use the classification to identify the highest exponent or power. Okay, so we're looking at a quadratic, and what you know about a quadratic is that it's second degree, and the highest exponent therefore is 2 because the highest exponent is the same value as the degree. The second step is list all terms in standard form from highest to lowest power. So if the highest exponent is 2, that means my first term, I'm going to write down f of x equals, first term is going to be x squared, gives me a power of 2, and then the next term is going to be one number down, it's going to have a power of one number down, which will be 1. So x to the power of 1. We don't write down exponents of 1, so typically that's left as blank. Next, we're going to separate terms with plus signs, so we go ahead, and there's only 2 terms here right now, so we just separate those with plus signs. And then finally, we add in the coefficients, A, B, C. So we should have a coefficient of A in front of the first term, and a coefficient of B in front of the second term. And then this last bit here is C is a constant. We always have to add a constant at the end. So once you have terms that no longer have x's, you've got your x to the power of 1. After that, you're going to have a constant. Why? Why do we have to add a constant? Well, here's the truth. Even though we don't write down the variable x for that very last term that has a constant in it, it actually is there, because if you look at the powers, we start at the highest power for quadratic, that was 2, and then we just keep going down by 1. Next power will be 1, and then the last power is 0. But because anything raised to the 0th power is equal to 1, cx to the 0th power is actually just equal to c times 1, which is equal to c. So that's why that x to the 0th power is not shown there. If it helps you to write out the x to the 0th power as you're doing this, that's totally fine. But in the end, we're not going to show that x to the 0th power, just because it just kind of gets confusing with all of those numbers and things. All right, here's your practice. You're going to write out the general formula for the following polynomials, using the same format with the quadratic as an example. So I should see f of x is equal to something next for the cubic, quartic, 5th degree, and 7th degree. All right, pause the video as you work through these problems, and then there's going to be one more practice after this. Okay, the second part of the practice is using x values in a data table to fill in the data table with the general formula. Now, just to remind us, the purpose of this video is to prepare us so that we can be able to write the formula or equation from a data table. And this step is really important for how we're going to do that. So that's why we're practicing this. All right, so let me show you what I mean. So we're going to use the quadratic as an example again. What we want to do is we want to fill in the f of x column, and we're going to do that by plugging x into the general formula. So when you go and do your practice problems, this is what I'm looking for. I'm looking for an x column with these numbers, 0s, 1, 2, and 3, and an f of x column, f of x equals, with the general formula. So for quadratic, it's going to be ax squared plus bx plus c. Now all I need to do is start filling in this column here by plugging x into the general formula. So let's start with 0, and I'm going to do my work on the side, not in the actual column, just because it's going to make it so much neater. So for the first one, I'm plugging in 0 in for x, so I get f of 0 is equal to a times 0 squared plus b times 0 plus c. And I know 0 squared is going to be 0, so what I'm left with is f of 0 equals a times 0 plus b times 0 plus c. So that's what I'm left with here when I do all the work out. Now a times 0 is 0 and b times 0 is 0. So what I have, once I've combine like terms and simplified, it's just C left. And so in this data table, I'm going to write in C. And that's it for the first one. Now we're going to go into the next one, which is where x is 1. So I'm going to substitute 1 in for x. And I get f of 1 is equal to a times 1 squared plus b times 1 plus c. 1 squared is 1, so what I'm left with now is a times 1 plus b times 1 plus c. And a times 1 is just a, and b times 1 is just b, so what I really have after I simplify this is a plus b plus c, and so that's going to go in here. So again, all I'm doing is writing in the data table what I get after I plug in my value for x and simplify the expression. Next, we're going to do f of 2. So I'm plugging in 2 for x, and I get f of 2 is equal to a times 2 squared plus b times 2 plus c. 2 squared is 2 times 2, which is 4. So what I have now is f of 2 is equal to a times 4 plus b times 2 plus c. And if I try to simplify this or combine like terms, I notice that there are no like terms, but there's another way of cleaning this up in a way that looks more agreeable to us, what we're used to seeing. So a, b, and c, even though they represent coefficients in the general formula, right now they're just variables because they're just letters representing some number that we don't know. So because they're just variables, we like to put the numerical values first. So this 4 is now going to go in front of a, and the 2 is going to go in front of b. So what I'm going to get now is 4a plus 2b plus c. This is just easier for our eyes. These two expressions, a4 plus b2 plus c, is the same as 4a plus 2b plus c. They're the same things. All right, last but not least, we're going to plug in f of 3. So plug in x for 3, and we get f of 3 is equal to a times 3 squared plus b times 3 plus c. F of 3 then is equal to a times 9, because 3 squared is 9, plus b times 3 plus c. And again, we want to move the numbers in front of the letters. So when I go and put this into the table, I'm going to write it as 9a plus 3b plus c. So what you're going to do for practice is you're going to do the same thing using linear data table. You're going to fill in a linear data table. 0, 1, 2, and 3 are your x values. And a cubic data table, again with 0, 1, 2, and 3. So remember, this work was all done so that we can be prepared to get the formula from the data table, building that road there, in our map. Have a quality weekend.